Okay, welcome. We would like to look at lecture 11 now. We did part of this in class. We're going to finish up for us. So let's get started. And lecture 11 talks about combining functions. We had the algebraic functions, addition, subtraction, multiplication, and division, and then composition. And the tricky thing that we're going to see in all of these examples is how composition works, but also finding domain. Okay, in class we covered these functions, the algebraic functions, which are just found by combining two given functions. And of course this extends to more than just two. And we saw that if you have f plus or minus g or f times g, the domain of the new function is going to be the intersection of the domains of the individual functions. And if we call those domains A and B, it's the intersection of A and B. Now, if it's division, we define it the same way. F over G is the function f of x over g of x. It's also got to be the intersection of f and g, but we have to make sure that g of x is not equal to 0. So we have that added condition. Okay, let's do an example. Okay, we'll start out with a pretty straightforward functions and see how they work. So we have f of x equals x cubed, g of x equals the square root of x, and we want the domain. Now we did this in class, so I'm not going to write it all out, but we saw that f has no restriction on the domain, but g does. And so the intersection is just, in this case, the domain of g. The restriction on g will be the restriction that creates that intersection. And then we said, okay, f over g of x is just the quotient of the two functions, and it looks like this. And at this point, we know that the domain is from 0 to infinity. We also know that x can't be 0, because that would give us 0 in the denominator. All right, with that in mind, we go ahead and simplify. So we just did the algebra, and you can look at this later. Notice that we have the square root of x to the 4 times x. That comes out as x squared. So f over g of x is x squared times the square root of x. And then the question is, what's its domain? Now clearly, x has to be at least 0. The question is 0 in the domain of this function? Okay, now if you just look at the end result, you'd say, sure, 0 is included. But look at the beginning. We had to exclude g being 0 because it's in the denominator. So the domain is really 0 to infinity, not including 0. Okay, because it was excluded at this step. Doesn't matter how nicely we simplify, that original restriction still is there because that's how we built the function. If I wanted to find f over g of 0, it is f of 0 over g of 0, which would be 0 cubed over the square root of 0, which is clearly not defined. That's a problem. Okay. We had looked at one other example, and I'm going to finish the next one for us. Okay. And here we have two functions, and we want to simply add them together, and that's no problem. It's the domain that's the issue. Now domain f, of course, because it's a square root, has to be greater than or equal to 0. And in g, what's under the radical has to be greater than or equal to 0. Solve that inequality, and you can see that. Be sure you remember to flip the inequality sign, and I get from minus infinity to 1. And so our domain is where those two intersect. So f goes from 0 to infinity, g goes from minus infinity to 1. They intersect just in that region, so the domain is from 0 to 1. It does include the endpoints because the function is defined at 1 and it is defined at 0. Okay, and of course then you just add them by adding f and g, and that's our function. We had already seen this in class. Okay, now this one we did not do, so let's look at it. We want to find each function and its domain. So what's the domain of f? Well, it's everything but -1. And the domain of g? It's the same. Okay? So f times g of x is just f of x times g of x, which is 1 over x plus 1 times x over x plus 1. And the domain has not changed. Okay, it's everything but -1. And then we can rewrite that as a single fraction, and we get the domain. And I don't need to write it twice. It's right there. Okay, now what about f over g of x? That is f of x divided by g of x. Very natural. Okay? And f of x is 1 over x plus 1, and g of x is x over x plus 1. And if we look for domain restrictions, we see that x can't be -1, but we also know that g of x can't be equal to 0, because if it is, I'm dividing by 0. And that will be true when the numerator is equal to 0. So x can't be 0. So those are the two restrictions that we have, and they're both in play. Okay, does that make sense? Okay, let me see if I can get this focused a little better for you. All right, so now with that in mind, now we simplify. That's 1 over x plus 1. It's a complex fraction. We know it means division. And that's 1 over x plus 1. And we know we flip that to accomplish that operation. The x plus 1's cancel, so it's 1 over x. So f over g of x is 1 over x. Now the question is, what is its domain? Well, clearly x can't be 0. Okay? But we also know that x can't be -1. Now if you just look at the answer, you'll say, oh, x can't be 0. That's the domain. But we also have to remember this is how it was formed. And if you look at this step, clearly x can't be -1. And that's exactly what we had found up in our first step as well. So what is the domain? It would be everything but those two values. So it's -∞ to -1, -1 to 0, and then 0 to infinity. Please make sure that you know that. See why that -1 is also included, even though the end result certainly would not indicate that. If I just looked at this and said, oh, I'd say, oh, well, x can't be 0. But it also can't be -1 because of the way that we made that function. Okay? All right. Then we started looking at composition of functions. And we said function composition is just a new function that we form again by combining our two original ones, but in a very specific way. We start with what we call the inner function, g of x, and then we apply f to the result. We usually write that as f of g of x. But it might help you to put the brackets there to start with. It says take g of x first and then take f of the result. And what about domain? Okay, well here's what f circle g does. You start with x and you apply function g to get g of x. Okay, so what do I don't know about the domain? It's got to be the domain of g, because that's what I evaluate first. Then I take this result and I plug it into function f, and I get f of g of x. Okay, so I go from x to g of x, and then I plug g of x into the function f to get f of g of x. And so I have to make sure that x is in the domain of g, but also g of x. So x is in the domain of g, g of x is in the domain of f. It has to be in order to be able to do the composition. So those are the things we have to watch for, and the key one is the first one, that you have to start with the domain of g. Okay, let's look at an example. Okay, f has domain minus infinity to infinity. G has domain x minus 3 has to be greater than or equal to 0. Okay, so those are the domains of the individual functions, and let's see now how it works. All right, first of all, f circle g of x is the same as f of g of x, which is f of the square root of x minus 3. Okay, I take g of x, and notice that that immediately puts in the domain restriction that x has to be greater than or equal to 3. Doesn't matter what else I do to the function, that has to be true. Okay, because that's how we're constructing the function. We do g of x first. Okay, now what does that equal? Now I go back and I take f of that quantity. F says square it. So I simply square that quantity. The square of a square root is just x minus 3. And so f of g of x is just x minus 3. And what is its domain? We have to go back to the way it was constructed. It was constructed by applying g first, so that restriction has to be there. I'm sorry, that's 3 to infinity, not 0. Okay? Let me write that as 3 to infinity. Right, does that make sense? Because we started by applying g, and that had a restricted domain, so our end result, it doesn't matter that it's just x minus 3. It still has the same restriction. You'll get to practice lots of these in your homework, so make sure you understand why that's true. Okay, let's go the other way. G circle f of x is what? It's g of f of x, which is g of x squared. Okay? Domain? So far, no restrictions. X squared, remember the domain of f can be any real number, so no restrictions yet. Okay? And so that's g of x squared. What does g tell us to do? It says replace x with x squared, because you're taking g of x squared, so it's a replacement. Okay, now that will clearly have a restriction. What's under the radical is going to have to be greater than or equal to 0. Okay, now we haven't seen how to solve that inequality yet, so let me just give it to you. Don't worry about it, we won't ask you to do one at this point, but it will be minus infinity up to minus the square root of 3 and the square root of 3 to infinity. And I think you can see it makes sense why it would look like that, but don't worry about actually finding it. So that is our function, and that is its domain. Okay? Questions? Look at that and be sure and ask if you've got questions. Okay, let's do another, but we're going to take a break right now.